All right, hello everyone and happy Friday. We are here to do our weekly studio review. This was our first real studio. This one actually counted for credits, and it seemed like it went pretty well, at least from what I saw. But I'd like to go through these problems real quick and talk about each one a little bit, make sure that the important concepts are all touched upon. Starting with this first one called High 1. You actually don't really need to do anything too much with the code for this one, but we do want you to take a look at this and make sure you understand all the different parts and what they're doing for us. If we take a look, we can start just by running the code, and then once we do so, down here it says enter a value for arg0, which is a little bit confusing. What does arg0 mean? But if you type in a name, like my name for example, it doesn't actually do anything. So I misspoke earlier. We do need to do at least one little piece of work down here at the bottom. It says we need to take the value that was typed in, such as my name, and say hello to that person. So in order to do that, we're going to need to add in on another print statement, like so. And we can easily say hello, right? That's not a difficult thing to do, but what we actually need to do after that is to take this name, whatever was typed in, using the scanner. So this is the line that creates the scanner for us. There's a little bit of magic happening here, a little bit of hocus pocus, but this is where the scanner gets created, and then this is how we use the scanner to read input from the user. And that's what we want to somehow incorporate into our line of code down here. We want to take whatever they typed in, whatever name was typed in, and add it to this hello message. And that name, we can see, has been stored into a variable. Specifically, it's been stored into a string variable because names are text, so strings make the most sense. And we can add it to our message down here using a process called concatenation. So concatenation is the act of using addition with strings, basically. So this is a string. We can tell that with the quotation marks. This is also a string. We can tell that because of the way the variable was declared, right? So if we use an addition sign in between two strings, it's going to take those two strings and stick them together. Let's try this out. Let's rerun this program now that we've added that line of code and see what happens. I'll type in my name, and it says, oh, it did work. There's the hello message. You can see it's all squished together, though, maybe a little bit too much. Computers are very literal, so if you want proper punctuation and such, you have to make sure you put it in there. So I put a comma and then also a space afterwards to make sure that there would be a space after the word hello, but before the whatever name gets typed in. And you should definitely try and run this a few times. Maybe try a few different names, and oh yes, looks like it's working much better this time, right? And then I would also, probably want to come up here and switch this to be a little bit more user-friendly. Say, enter your name, right? Instead of enter arg0. Nobody's really going to understand what arg0 is. So now if we try this one final time, here it says enter your name, and I type Simon, and it says hello, Simon. There we go. Perfect. So a very simple program that uses the scanner to do user input. That's a concept that we actually didn't get a chance to talk about in class last week, unfortunately, due to lack of time, but it's one that we're going to be using a lot over the course of this semester. In fact, we're going to use it on the next exercise as well. Let's switch over to that one. You can see that for this exercise, we're using the scanner quite a bit, and here's arg0 again, but also we see arg1, arg2, arg3. Actually, what we want to do is read in 4 different names and say hello to all of them as one group of people. So I'm going to start actually by changing these prompts. Enter name 1, right? Enter name 2, enter name 3, and enter name 4. So now it should ask us to enter appropriate things instead of arg0, arg1. Make it a little bit more descriptive, a little bit easier to understand. And we're going to have to do the same thing that we did last time, but maybe just a little bit more of it. So we're going to say system.out.println hello, and we're going to use our good friend concatenation, but this time we have to say s0 plus s1 plus s2 plus s3. We're going to use all 4 of these variables. Let's try it out this way and see what happens. see how close we are, I'll use, George, Paul, gosh, I can't type today, John, and Ringo for the names. And okay, so kind of a similar issue to what we ran into last time where, yeah, it kind of worked. I see all those names there, but they're all mashed together. And that's because if we look, there's no commas or spaces or anything in between them. I literally just smashed them all together. If I want to fix that, I have to come in here and I have to say, all right, put a comma in there. Notice that I used another concatenation operation. So we're going to use a whole bunch of concatenation operations to put this all together with all the commas and spaces that we need. We don't need one after the last name, right? Although for the last name, we probably would like some punctuation on the end. Oops, I'm missing a concatenation sign there. You can see that's why that one was upset. So for the one on the end, we'll just put like an exclamation point to cap it off. All right, let's try this one more time. Name one will be John, Paul, George, and Ringo. Ringo. Hello, John, Paul, George. And you can see that the punctuation works. I got the exclamation point on the end. And so now we have a program that can say hello to 4 people instead of just 1 person. Consider, what if I wanted to make a program that says hello to 10 people, or maybe even like 100 people? You could do it, right? But it would be a little bit tedious to have to create variables, 100 variables for the 100 different names. We're going to find a solution to that when we move on to our Module 2 material next week. So that's kind of an interesting problem to think about for the future. But for now, let's go ahead and move on to our next Studio 1 problem, which is this one that's called ordered. For this problem, we're reading in, not names this time, but you can see that we're reading in numbers, so 3 values, x, y, and z, and our task is to see if they're in order. Either they're all decreasing or they're all increasing in value. So we need to actually try this a few different ways, make sure that it works for both ascending and descending values. But first, let's take a look at how the scanner is used. You can see that instead of saying in.nextLine, it says in.nextInt. So I'm reading in not text this time, but numbers. And so we're going to treat those values a little bit differently down here as well. Now, a lot of students have taken programming before, and they really want to use something called an if statement here. We encouraged you not to do that because we haven't actually covered if statements yet. That's another topic that'll come up in Module 2. But in order to do it without if statements, I would encourage you to think about the fact that we are using data types this week. So we have ways to ask questions like, is x greater than y, or is y greater than z? We can use a Boolean data type to help us answer these questions. So one thing that we want to check to see is if x is less than y is less than z, and so we would say that is, ascending perhaps. And you might try to write this something like this: x is less than y is less than z. In math class, this makes perfect sense. But here's how the computer thinks about this, and here's why you can see that the computer's unhappy and says, I don't know what to do with this information. It's going to look at this first part, and it's going to say, is x less than y? And that is either a true or false statement. It depends on what the values of x and y are, but regardless of what they are, it's either true or false. So if we think about what that is, what's going to happen next is going to take that true or false value and then try and see if it's less than z. And that doesn't really make sense, right? We kind of lost, or we're off the path now. We're comparing things that don't make sense. So why is it that this doesn't work like this? Well, it's because the computer is only able to compare 2 things at a time. It's not actually able to compare all 3 things at a time like this. We have to write it as 2 separate statements and then glue them together. So what I want to be true is this, but the way that I'm going to say that is I want x to be less than y, and why can't I find my, oh, there it is. And, those are 2 ampersands, I want y to be less than z. I'm saying the same thing, I'm just kind of breaking it up into 2 chunks. Now these are called, this AND operation is called a logical operator, and I think it's kind of useful to think about the what's called the truth table for these. there's only 4 possible combinations that it could be, right? So if we have 2 inputs, x and y, then x and y would be the output. And there's only 4 possible ways that you can actually configure this. Since Booleans can only have 2 possible values, that means that x can be true or false, and y can be true or false. And that allows us to create what's called a truth table, where we just kind of specify all of the possible combinations, as I'm doing here. I'll explain this once I'm done writing this last one. All right, so here's the truth table for the AND operation. And the way to think about this is to see that, okay, in order for the AND operation to be true, both the left-hand side and the right-hand side of the AND operation have to be true. Excuse me. If either one of them is false, or if both of them are false, then AND is going to be false. So I'm saying that x and y have to be true in order for the AND operation to be true, which is why this statement works, right? We want this to be true, and we want this to be true as well. All right, so you could think that we could also write a very similar kind of statement for descending that would just say x is greater than y and y is greater than z. And that'll also work, right? But what we need to know is whether this is true or whether this is true. So that leads us to a second kind of logical operator, the OR operator. We're going to make one more Boolean variable. I'll name it ascending or descending. And it's literally going to be ascending, and then I'm going to put these characters. This character is called a pipe. It is above your return key on your keyboard, descending on the other side. So think about what this operation does. It feels a little bit different from AND. In fact, we could even write out the truth table real quick if we wanted to. Let me see if I can get it back real quick and write out the truth table for OR. I'm going to copy this, and then there we go. Paste that in, and then just tweak this. So instead of the AND operation, I want this to be OR. And what that means is that if the left-hand side or the right-hand side is true, then this whole expression will be true. So if they're both true, it's true. But since this is true, that means that this one becomes true, and this one also becomes true. Only if both the left-hand side and the right-hand side are false do we get to the situation where the OR operation is also going to be false. So this is the truth table for the OR operator. The AND and the OR operator are going to be used all the time. Basically every assignment, many of the exercises that we look at. So these are definitely good things for you to understand / memorize, right? Get used to using on a regular basis in this class. And once that's done, I think we just need to see our result, which we can do by printing it out. Okay. So I want to run this a few different ways, right? Let's try this out. First, I want to check to see if it works when the numbers go up. So if I say 3, 4, and 5, it should be true, right? Because those are in order, they're ascending. And it tells me that, yes, that is in fact true. Let's try it again. This time we'll do descending. So I'll do 5, 4, 3. And it tells me that, yes, that's also true. But there's still another condition that we have to check, which is that what if it's neither, right? What if it's neither ascending or descending? Let's try 4, 5, and then 3. And it tells us that false. These are not ascending or descending. They're not in order. These values are not ordered the way that we've typed them in. I would encourage you to keep testing this with various combinations until you're satisfied that it's actually doing what it's intended to do. But the real purpose of this was to introduce you to these nice logical operators, the ANDs and the ORs. In fact, I think we're going to get some more practice using those on some of the other studio exercises. First, let's take a look at this, let's take a look at this average. And this time we didn't give you any code for it. We're asking you to start from scratch, so a brand new program. No program exists right now. We're about to create one from scratch. So we're going to go ahead and right click here like it says. We're going to make a new Java file. Specifically, we're going to make a new class. Everything that we create this semester is going to be in a class. If you take upper level comp sci classes, you might run into some of these things later on. But for this class, everything that we're creating is what's called a class. And we're going to name it average like this. Once we do so, we can see the average file pop up here on the left-hand side. And it wants us to put in a couple of things. It wants us to put in this part, which is called the main method. So this is what tells the program that we're about to do some stuff. And make sure that you have not just the opening bracket, but also the closing bracket here in order to make it happy. And then we also need the scanner. We need the stuff to do scanner to read in 2 integers. Well, actually, I just had the scanner read in integers over here. So why don't I just come over here and grab this code? Right? This is programming, actually. Realizing that, hey, I've seen something that does similar to this. Let me go ahead and look at that code and tweak it a little bit until it suits my needs. You can see that as soon as I pasted it in, it was smart enough to put in this line up here for me, which is necessary to run the code. And now we're ready to actually do the work that we've been asked to complete for this problem. They want us to read in those 2 integer values and then print out what the average of them is. So it could be a double, right? It could be a double. That's something that we need to check for. In fact, I see a lot of students do it like this when computing the average. They would just say something like x plus y over 2 and store it in a double variable like that. And then the last thing that we need to do is just make a little print statement. It says average and concatenate our variable on the end of that print statement like so. I think this is a reasonable first attempt at this problem, but let's try it out. If I do it for, some simple values like 5 and 7, whoops, well, we already have a problem. We already seem to have run into an issue. This is way off. 5 and 7 is not 8. So let's take a look at our math, and oh, that's right, there's this thing called order of operations that happens, which is going to do the division here before it does, the addition. And so I think that's maybe where things went wrong. Let's use some parentheses, right, to make sure to force this addition to happen first, and then we divide by 2. Okay, let's give that a go. And we'll try 5, and we'll try 7. And now it tells us the average is 6. That's great. Let's try another example where we try 5, and we try 6. And now it tells us that the average is 5. So, okay, it's working for some values, but not for others. And why? Why is that? Again, it comes back to the topic this week, which is data types. So looking at our arithmetic again, I see that x is an integer and y is an integer. So when I add those 2 together, I'm going to get an integer back out. If I add 5 and 6 together, that's going to give me 11. 11 divided by 2 is 5.5. But since we're in computer science, we also have to consider what the data types are. So I'm doing 11 as an integer divided by 2 as an integer. That's going to give me an integer back out. And 5.5 is not an integer value, right? So what do? That 5.5 can't stick around. It actually just chops it off. It doesn't round. Notice that if it rounded, it would have rounded it up to 6. So rounding isn't what's going on here. It's just chopping that decimal off, forcing it to be an integer value, and that shows us 5 down here. So how do we fix this? There's a few different ways you can do it, but we need to make something a double here, right? Calling this a double is too late. Assignments are, these operations are performed from right to left. So this math is happening before it gets created into this double value. So I need to make this a double, or I need to make this a double somehow, which we can do. We can actually do both. We can make this a double by saying 2.0, or we can also, make one of these values a double by simply putting something out in front of it like this. We put the word double in parentheses. This is what's known as a cast. So when you see a cast like this, it's going to take the value, in this case y, and turn that into a double. And now since y is a double, the result of this will be a double, the result of the division will also be a double, and that should fix our problem. But let's try it out and make sure that that's actually the case. Now if I enter 5 and 6, I get 5.5 back out for my average. It looks like it's working. Yep. Great. All right, on to the final problem, which is honestly one of my favorites in the whole class. We're going to do a program to check to see whether years are leap years or not. Same as before, we're going to create a new class for this. So a new Java file class. We're going to call it leap year. Just like before, we need the public static void stuff, and we also need a scanner, but this time we just need one number. So I think this code is enough to copy over to get us started. Okay. It's not going to be called X. It's actually going to be a year, because what we want to do is detect leap years. Here are the rules for leap years. Either it must be divisible, so all of these have to be true, right, or false, depending on what the conditions state. So if a year is evenly divisible by 4, that's a leap year, unless it is also evenly divisible by 100, right? But if it's evenly divisible by 400, then that prior rule doesn't apply, and those are considered leap years. So these are all separate conditions that we can check. If I give you a year, you could ask these questions. Is it divisible by 4? Is it divisible by 100? Is it divisible by 400? Those are all questions that we can ask and get the computer to answer for us using an operation called modulus. So the modulus operation is an operation that is similar to division, but it doesn't give us the result of the division. It actually gives us the remainder from the division operation. So if I say something like 4 modulus 3, where this percent sign is the modulus operation, that would give me a result of 1, because 3 goes into 4 one time, but there's 1 left over. Interestingly enough, right, if I say 7 modulus 3, that answer is also 1, because 3 goes into 7 twice, but there is still a remainder of 1. So, that's the result that we're going to get back from that modulus operation, right? So in this case, we're actually looking for very specific things to happen. We're looking to see if certain numbers are divisible, and if they are evenly divisible, then the remainder that we're going to get back would be 0. So let's start trying to type some of these out by checking this very first one. I want to see if the year that we've been given is evenly divisible by 4. Either it is or it's not, which tells me that a Boolean would be a good variable here. So I'll call it divisible by 4. I'm going to say x modulus 4, but I'm looking for a very specific result from this operation. I want only the situations where that value is 0. So I'm looking for the case where x mod 4 is equal to 0. But be careful. Notice that I used a single equal sign here, but that's not the same as what this equal sign is doing, right? In fact, we need to make a distinction between these two operations. This is variable assignment. I'm taking a value and storing it in this variable that I'm trying to create. Whereas over here, I'm kind of asking a question. I'm saying, is this equal to? I'm trying to check for equality. I'm not assigning something. I'm trying to check for equality. So there's a difference. And to signify that difference, we actually type that differently in our code. In order to check for equality, we use what's called double equals, right? So now I'm asking the question, does 4 evenly go into x, right? Is the remainder of x divided by 4 equal to 0? If it's true, then this variable will be true. And if it's false, that variable will be false. And we can write similar statements for the rest of these, right? So it is not evenly divisible by 100. Well, let's check that out. Boolean divisible by 100 equals x modulus 100 is equal to 0. And the last condition said if the year is evenly divisible by 400. Okay, so Boolean divisible by by 400, I'll say x modulus 400 equals 0. So these are the three things that we're checking for, but now we kind of have to tie it all together. We are going to say that something is a leap year if it is divisible by 4. So if divisible by 4 is true, then we want is leap year to be true. But only if it is not divisible by 100. So we have to think about how that factors into things. We have to say and not divisible by 100. But then wait a second, there's an exception to that. If it's divisible by 400, then it doesn't matter. So over here, notice how I use parentheses to take care of the, to kind of force the order of operations over here a little bit. Divisible by 400. Let's talk about this statement. This is a very computer sciencey line of code right here, right? I want to run through this program maybe a few times even, make sure you understand exactly what each of the component parts are doing for us. But trying to read this out in English, right? I'm literally saying that whatever the value of x is a leap year if it is divisible by 4 and it is not divisible by 100, or if it's divisible by 400. So you can see all of the possible cases in which we can compute a leap year. The last thing that we would need to do is just simply print out true or false. Print out is leap year, print out the result of that computation. Let's try it out with a few examples. You know, we give you some examples here. So 2020 is a leap year because it's divisible by 4. So let's go ahead and try that. If I say 2020, it tells me true, right? Okay, but 1900 is evenly divisible by 4, but since it's also divisible by 100, that makes it not a leap year. So let's go ahead and try 1900 and make sure that works out. And it tells me false, right? It is not a leap year. And then finally, 2000 is a leap year because it's evenly divisible by 400. But what I would actually like to do is not just show you that these work, but maybe show you in a little bit more detail what's happening by using the debugger. So let me go ahead and set a breakpoint. Actually, I prefer to make sure to set my breakpoints after any scanner action is over. So I'm going to set mine right here at line 11. And then I'm going to start it up in debug mode, like so. I'm going to use 1900. I want to walk through what happens when we use 1900 as the year that we're checking. The first thing that it does is it checks to see if 1900 is divisible by 4. And it is, right? It's an even 100, so it is going to be divisible by 4. When I click the step over button, we'll see over here that divisible by 4 is set to be true. The next thing it does is it checks to see if it's divisible by 100, which it also is, right? So when we step over here, we see that's also true. Then it checks to see if it's divisible by 400. It is not divisible by 400, so we step through one more time. We see that, okay, this third variable is false. And now we have to figure out this line of code. The first thing that we're going to take a look at is inside of the parentheses. So this is true. This exclamation point here is called a not operation. So it takes whatever this value is and flips it. So because this is true, this actually becomes false, right? And because this is false, that means that this entire AND operation, even though this is true, it's going to be true and false. So true and false means that everything inside of this parentheses is going to resolve to be false. Now we have to resolve the OR operation. So we have a false on the left-hand side of the OR operation. This value, as we can see from the debugger, is also false. False or false means that false will be the result of the OR operation, and that's exactly what we see for the value of is leap year. I would encourage you to walk through this maybe with the year 2000 example and see why that one manages to correctly predict whether it's a leap year. Walk through this line of code in particular, right? That's where some of the tricky logic is happening, but also make sure you understand what these modulus operators do as well. All right, everybody. I think that is going to do it for this week's studio review. I guess just to kind of wrap things up here, there are a few creative exercises down here where we pick which data type would be appropriate. So for example, if I look at this one, the number of people you can take in your car, right, that obviously wouldn't be a string because that's not a number. And obviously I don't think would be a double either because, you wouldn't carry half of a person in your car. That would be a very dangerous thing to do if half of their body was outside of their car. So an int, right, would be the most appropriate size for this one. Meanwhile, the price for something is probably not going to be an int because that money usually involves decimal places, right? And there are other interesting situations where, for example, the address does contain a number, but I would actually say it's probably more appropriate to use a string because we're not doing arithmetic with that number. It's more for conveying information than anything else. But that's going to do it for now. Just as one final reminder before we kind of wrap things up, we do have our first quiz on Monday. So I would like to remind you all that there is a practice quiz with quiz questions from past exams and quizzes over this material. These are all past questions that have been asked on quizzes and exams over this material. So please take a look at that before coming to class on Monday. Please take a look at the homework assignment. That's another great way to practice this material. And have a great weekend, everyone. We'll see you in lecture on Monday.